Awesome. And looks like we're good. So hi everyone. Welcome to the Dapr community call for September 7th, 2022. This is community call number 68. My name is Nick Greenfield. I'm the host for today's call, and I'm also one of the Dapr maintainers of the documentation repo. So today's call, we have an exciting agenda, three different topics that we'll go through. First, keeping up with our tradition, a DapperCon update, and then we'll look at and walk through a proposal that's currently open on GitHub for the Cryptography API. Archer will walk us through that. And then Yaron will wrap things up with the pub sub multi-tenancy topic, which is slated for Dapr 1.9. And as always, if we have time at the end, we'll have an open discussion where anything that's top of mind that's Dapr related, we can use that time to discuss. We will, if there's any questions at any point during this call, we'll try to make time in between the topics to address those questions. So please feel free to use the chat, or if you were asked to be unmuted, I can unmute you and you can ask your question. So without further ado, we're going to get into today's call, starting with a DapperCon update.
Okay, so currently for DapperCon, we have completed accepting submissions, and we're in the process of actually finalizing the agenda. So we're expected to submit our final agenda to CNCF on Monday. So we're going to have a final approval meeting with the maintainers this Friday. And we should hope to be able to start reaching out to everyone next week to kind of inform people of whose proposals were accepted, whose were not, etc. So based off of the limited time frame we do have for DapperCon, we'll go ahead and kind of just let people know which proposals are in DapperCon and which ones didn't get a chance to make it this time around. So yeah, that's all for my update here. Are there any questions around this? Cool. In that case, yeah, so that case, look out for communications from us next week on if your proposal was accepted or not.
Cool. DapperCon's coming up. Okay, thanks for that update. Now we're going to move into a proposal walkthrough of the Cryptography API, where Archer, feel free to either share your screen or I can walk through the slides.
Can you hear me now?
You sure can.
Okay, awesome. So first, we're going to look at how would you pose to encrypt a message. So this is based on the discussions I saw on the chat on the issue, and there are some things that I had some ideas, and I'm going to post this after this call on the issue itself. So
hey Archer, real quick, can I ask you a quick question?
Yes.
Can you talk a little bit about the Cryptography API and why this would be useful and why this is something that the Dapr project is exploring, and just setting a little context here? I think that'd be really helpful before we get into the actual the API itself.
Yes, absolutely. So this proposal is about allowing applications to encrypt, decrypt, sign, and verify payloads on the app. So that is the rationale behind it. So today, if you want to do that, you need to get the key for the secret store, and you need to have your own cipher implementation in your app, and then encrypt and handle key rotation, everything within your application directly. So this is going to offload that functionality to the sidecar. So I hope that clarifies. Any other questions on the motivation and context for this? Okay, so I'll proceed. So here we're going to look at the encrypt API first. So the first way is going to be to post a message to encrypt, and we're going to use like plain text as the name of the attribute, similar to how I saw that HashiCorp Vault does. So same terminology. So it's familiar to people using Vault, for example. And you can also pass a basics for encoded binary. So So we have a little metadata attribute that we can pass to let the Dapr sidecar know that this payload is actually binary, and it should be decrypted. That should be decoded before encryption. And then the response is going to be as simple as the cipher. The cipher text is always basics for encoded. Even though it's called text, that's something I noticed in the HashiCorp Vault API. And it seems to be use ciphertext as a term, common industry terminology, even though it can be binary data. And very important, you're going to also return metadata. And the metadata here is going to be mainly used for key version. So it's recommended that every cipher, every component that implements the API handles key versioning, because that's the way you can decrypt old data after the key is rotated. So the old keys can still be used to decrypt, even though a new key is used to encrypt. So, so that is how you would encrypt a payload. Next slide, please. All right, thank you. So the next slide will be to decrypt. To decrypt, again, you pass the same payload that you received when you encrypt, you pass when you decrypt. And that way you get the text back. So it's just some symmetry between those two APIs. The request from one is going to be the response for the other one, and vice versa. So, and also in the response, you're going to know if the plain text is basics for encoded. So you can simply basics for decode that on your on the SDK, for example, if you use the HTTP API. Can you go next? It's not in the proposal yet, but I'm gonna paste this after this community call, where we should probably have, and by the way, it's up for discussion, it's not decided yet. We should probably have the configuration about on the cipher to be part of the component itself. So we can, that would offer like a built-in cipher, which means going to be implemented in memory, and you can pick the cipher you're going to use, the secret store that the cipher going to use to retrieve the encryption key, and the encryption key name. So this way, the built-in cipher can retrieve its key and keep that in memory to encrypt and decrypt information for you. And if you go back, if you look at my cipher here, look, can you go back one slide, please? My cipher will be the name of the component in the URL. Okay, so that is following the same pattern that we have on the state store APIs and other APIs in Dapr. So not different, nothing different here. So can you go please move forward? One more. And I also took a look at the HashiCorp Vault implementation for the API to encrypt. And this, of course, will be in the proposal where you can specify HashiCorp as the cipher here, and key information, which type of encryption key you're using, you're going to be part of the metadata. So yeah, so that is what we're going to propose now for the cryptography API as a follow-up from the discussion. And I'm happy to have questions and also engage in discussion of the issue.
Yeah, so thanks for that. We do have a couple of questions. I see Doug has his hand raised. Doug, you should be able to unmute and ask your question.
Yep. So very cool, Arthur. Just a quick question. Why do you require everything to be wrapped up in JSON? Originally, my original question was going to be, why do you have the plain text thing, and why not just let binary data flow through? Then I realized you need to do something because you're encoding everything in JSON. But then I realized, well, why are you encoding everything in JSON? Why not just take the HTTP body as however the user wants to send it, whether it's binary text or whatnot, and just treat it as a bunch of binary data and just encrypt that? Why do you require JSON?
Well, I thought about that too. So this one was me following the current APIs we have for Dapr. Now, when it comes to gRPC, that would definitely be a structure, right? because the gRPC has a structure. So we're gonna replicate this in gRPC. But for HTTP, you're right. We can have just the payload information directly as raw. We can have the metadata be part of the HTTP headers, right? And we can also handle content type, so we can know if the data going through is binary or if it's text. If it is going to make a difference to the cipher, probably it's not going to make a difference. But yes, we can definitely make this API different from the others and have just use straight HTTP protocol. That is a possibility too.
Okay, I was just curious. I don't have a huge opinion either way, but if you do just take the body as a chunk of binary data, whether it's text or not, I don't even think you need the metadata flag. You can just treat the body as a blob and then just put on to the
That is true. That is true, because the HTTP handler will receive a byte array, and you can just encrypt that. That's a great point. The metadata, I don't know if we might want to use the metadata if we want to decide to put that as part of the payload when we encrypt. We can bundle that, because when we decrypt, we can return the response with the expected content type already. So the user will like see an actual, let's say he encrypts an image, he can see back the image with the same API back. But it is a possibility, and I thought about that. I want to just show this first, where like this will be like adhering to what the Dapr APIs look like today, but we can definitely make that way, and I think it might end up being a better HTTP experience.
Yeah. Okay, I was just curious. Thank you. But very cool.
This is your own. So we can actually do that quite easily, because we do support metadata through query parameters today. So we could actually look at the content type for the binary format, and then get the metadata from query parameters as we do today, right?
Yes, we could do that as well. So I think just passing the payload straight into the HTTP request might be a better solution. If we want to deviate a little bit from how the other APIs look like in Dapr, I think we should definitely do that.
Yeah.
Tiago had a question.
Yeah, Tiago, you can unmute and ask your question if you'd like.
I think it's in the same realm. Is we have a is binary metadata on the response, and I was wondering if it's even worth having it. I get the value of the is binary on the request, but because it's kind of instructing, you have to base64 decode this, but in the response, do you know if it was originally plain text or not? I mean, it seems that you don't know what exactly might be coming out of your response, right? When you decrypt. And you have the same on the response as well as it's binary. But in the response, I think might be wiser not to have that assumption. Or even to make the response and the request pretty much the same, I would suggest the opposite. You tell me that this is plain text. I assume everything is base64 on the request and the response, because it makes it consistent.
Yeah, that is true. If you proceed with this API, we can assume everything is binary unless you tell the otherwise, and you can say is plain text instead. We can definitely go with that approach, because maybe go ahead.
Otherwise, you have to keep metadata within the ciphertext saying this is plain text, or this was supposedly to be plain text. Otherwise, you where is this flag coming from in the response, right? Where are you getting this knowledge from?
This information is not necessarily used in the ciphertext, because the ciphertext is always going to be binary, right? But when you encrypt, but I agree, when you decrypt, you're going to need to know that this is expected to be text.
And unless you store this information, you have no idea if it is or not.
Yeah, that is true. That is true. Yeah, that is true. I think that would still be the problem, even if we use the proposal that Doug was talking about, where we go straight into the GTP body. We're gonna need to save some information. I think I mentioned this earlier in the call. we need to save some information in the ciphertext about the content type when you're reading the payload, because that can allow you to get the HP payload straight and even rendered if you want. So that if that's the experience we want, we can definitely save that information. If not, we can just return octet stream all the time.
Yeah. The other thing I was thinking is, so actually, sorry, two other things. One is develop encryption. Which is the model of encryption you're assuming for this component? So this component, every time you encrypt, you request the downstream service to perform an operation, right? There's no assumption that I'm holding the key within memory to perform envelope encryption, right?
There is one of the components does. Can you move forward a little bit into the slides, please? One more. Yeah, there you go. That one, no, go back. That one will be in memory. So it's like the built-in one that you have more control over the configuration, and we can have an opinion about the envelope. If you can move forward, the other one will be using HashiCorp API. Now, we can still decide to have an envelope on the Dapr runtime, regardless of which component we use. So we still can decide on internal structure for message envelope, which I think is valid.
Yeah, because I mean, the concern that I'm raising is that depending on the downstream service that you have, if you are using a cloud provider, every encryption operation is paid, right? And sometimes what you do should not decrease the level of security, but to decrease your costs, is that you acquire the key temporarily in memory, and you create a one-time key, and you encrypt this key, and you send the key and the payload, and that's how we store. That's how we call envelope encryption. Because you acquire the key content or something that allows you to encrypt the key, and you are not asking the key store to encrypt every single request. We are doing that in memory. So you save on this every single request as an encryption operation or a decryption operation.
That is an interesting idea. We can do that. We would have a more opinion on how things are encrypted, but that is definitely a possibility, and we would do that in the runtime. So every component will have the same, I would say, steps, like cipher steps to follow. I don't know what's the terminology for that, but yes, we can do that. I've seen this before.
Okay. That's it.
But on the other hand, Vault is supposed to do that for you. Now, we can.
But Vault is cheap, right? For Vault,
yeah, Vault is cheap because yeah. But I assume, but if you want to do that, we have to do that for everyone. We cannot just pick and choose, otherwise becomes weird in Dapr when you have like different behavior per component. So we want to have a uniform behavior.
Yeah, I can stress on how important it is to have the uniform behavior. I agree on that, Arthur.
Yeah, okay, that makes sense. I think it's a great feedback. I think we can definitely incorporate that into the issue, where we don't delegate the encryption. We just generate a one-time key every time we encrypt, right?
Yeah, I can chime this on the issue.
Yeah, I think that would be really helpful. I think there's a lot of good points, a lot of good suggestions. I think if we could capture that in the proposal, that would be really helpful.
Yeah, I would definitely post after this meeting. I will post on the issue what I understood and what I think is the next steps. But yes, I think we can start with encrypt and decrypt, and then we can start implementing then the sign and verify as well afterwards. Okay, great. That's all I have.
Yeah, thanks, Archer.
Thank you.
Okay. Moving into the next topic, PubSub multi-tenancy, which is targeting for 1.9. Yaron, take it away.
Yeah, thanks everyone. My name's Yaron. I'm a Dapr maintainer, And Nick, I saw how you moved Arthur's slides, and I was going to share my own and move them, but now I'm going to ask you to move the slides for me too, if that's okay with you.
You got it.
All right, thank you. So this is what multi-tenancy for PubSub looks like in Dapr 1.8. Assume you have a Kubernetes cluster and you have two simple applications deployed to the same namespace. You have app 1 and app 2. App 2 publishes to a topic called order, and app 1 subscribes to a topic called order. And this works very well. But next slide, please. If you want to do something really simple like, A/B testing or blue-green deployments or even canary deployments for your apps, this is very hard to achieve today with Dapr and without Dapr if you're using a centralized message bus, because what's going to happen is that you're going to have two namespaces with two different applications using the same app ID, which means that if you have the same app ID, the consumer group name for the message bus will be app 1 and app 2. Actually, I updated this slide. Nick, can you just refresh it? Just exit it and share again. I think we'll be able to see that. Yeah, thank you. Great. So in this case, if you go one slide, if you go to the previous slide. Yep. In this case, there will be two consumer groups for app 1 and app 2. And then if we add an additional namespace, next slide, then it'll continue to be app 1 and app 2 because Dapr will create consumer groups based on the application IDs of the individual application. So if you want to change that, you would basically need to have something creep into your code to basically change the consumer group or the app ID name based on the namespace you're running on. And this is very cumbersome and painful to do. And so what we're targeting in Dapr 1.9, sorry, next slide, are namespace consumer groups. So the same way we can allow you to override the behavior of a consumer group, a consumer group with a consumer ID for UUID and pod name today. There is now a new construct called namespace, which you can put here. What you're seeing here is the Dapr PubSub YAML for PubSub Kafka. You have the consumer ID here. You put in these curly parentheses namespace, and what it will do is it'll give you this ability to use the same application ID with the same topics from different namespaces. So it will look something like this. Next slide, please. In this case, in Dapr 1.9, you'll have namespace A, namespace B, same app IDs on both sides. You'll have app 1 and app 2 subscribing and publishing from namespace A and doing the same from namespace B. But in this case, the consumer groups names, as you can see above here, will be prefixed with the namespace they're running in. So it'll be A.app2, A.app1, B.app1, and B.app2, which means that your code doesn't need to change at all. You can add additional namespaces. You can keep your topics the same. You can keep your app IDs the same. Your actually your entire deployment pipeline just remains intact, but it will support this. And yeah, this is basically it. This is already merged into the Dapr runtime. If you want to try this out, you can grab hold of the Edge version of Dapr and use the consumer ID section that I've shown. This works for all PubSub implementations. So this is a very consistent behavior. It'll be supported for each and every one of those. And we don't have docs for this yet. We're planning to get these in next week. And like I said, this is coming in 1.9. Thanks to community contributor Ollie Tomlinson for bringing this up. This has been a great discussion to have, and Dapr really intends to solve multi-tenancy at scale, not just for PubSub. Now, if you remember, if you go look at a few community calls back, I don't know which one exactly now, but we talked about solving multi-tenancy for state, which is probably upcoming into 1.10 or 1.11. So yeah, this is it. Back to you, Nick.
Question quick, if that's okay. Is there, you showed the declarative example for setting up the PubSub subscription. Is there also the code-based one? Is there a property in the Dapr config endpoint that would accomplish the same as well? Or is that not implemented yet?
No, so we have this construct today of consumer IDs where you can put in UUID or pod name, but these are all metadata based. They're not overridable by the API.
Got it.
Yeah.
Got it. So still you would deploy different metadata YAML for each namespace. That's the expectation.
Well, you need a component per namespace anyway. But that
Yeah.
parentheses thing, it doesn't change. That's actually the construct. So you don't need to actually put the namespace here. It's what you see here as the value is literally the value, and at runtime, Dapr will understand what namespace it's running at, and it will fill the namespace for you. So you don't actually have to hard code it.
Got it. So it's like a dynamic metadata value that gets injected by the runtime and
Yes,
the
exactly.
component. Yeah, cool. Makes sense.
So following along that question, does that mean that if you have an existing one that didn't have a namespace 1.8 and you add the namespace, it will change the name of the consumer group?
Yes,
So everything gets updated for you.
correct. All right, back to you, Nick.
Great, thanks, Ron. Looking forward to that in one night. Okay, so that wraps up the topics today. So that we're moving into the open discussion session. So if anyone has anything top of mind or related to any of the things that we've talked about in this call, now's the time where you can raise those questions now. I'm scrolling back through the chat, looking. I don't know, Deep and Shu, if you are still there, it looked like you had a question related to the cryptography API. Is that still something that you want to ask?
Okay, so yeah, my question was like, I saw that in metadata we have provided the algorithm as a component, like in crypto API component. So my question was like, would that feels like that should be part of request? Though there was an answer like we can override with query params, but it's still, I think like if I've used any crypto API, then I see a usage like crypto.aes, crypto. That algorithm, and then that seems like a simple within the request. So maybe we can consider those points like instead of metadata, like in the metadata instead of that in the request itself.
So providing the metadata, sorry, can you clarify, providing the metadata in the SQL query params versus is metadata in the actual payload itself?
Yeah, if you go, I think, to the 8th slide. Yeah, so I'm talking about this one, the AES-256 cipher algorithm that we are using over here. So I'm just talking about this thing, that instead of declaring it in the component itself, if we can just use it within the request, something like so, things like these.
I thought about that when I was designing this. The reason why I put in the component is because depending on the service you're using to encrypt, that information is embedded in the key that you generate. So when you go into Vault, for example, you don't specify that. That's based on the key that you create. That is the cipher, and everything is decided for you. So so that's why when I was designing the built-in component, I decided, okay, if these opinions belong to the service, for the component, it belongs to the metadata, not in the request, because in the request for Vault, I did not see an option for you to send to override the cipher you chose, the cipher for encryption. So that was the point that I made for this one.
Okay. The way I looked at it is like maybe means like the way I looked at it is like if I want to use any encrypt, decrypt, or sign verify, and if I want to establish a custom security protocol for myself wherein I'm using multiple algorithms, I looked at it that way, that I can leverage sidecar for that and having multiple algorithms.
Oh, you definitely can. In this case, you would have multiple components.
Yeah, we will have to have then multiple components for different algorithms. Correct.
Yeah, we have multiple components, and now it is a point where does the configuration about cipher and encryption key, does that belong in the component for like an ops concern, or does it belong to the code as a developer concern? The way I see this is like, I want to encrypt, right, and decrypt a payload, and the configuration about how to do that,
I think it belongs to the component, and that can change over time, right? And so that's how I'm seeing this. And if you need like different strategies in the app, you can definitely use different components. But that was the original the reason for this design, and that's how I saw Vault implementation. It was heavily influenced by the Vault implementation. So if you want to take a look at the Vault API, I'm happy to discuss that further. But there was a rationale behind it. It was basically my influence from the Vault API.
Yeah, I agree with you, Arthur. Actually, I think this should be a component level definition for sure. Just because, sometimes you might not want to give, a developer or anyone calling the Dapr API the ability to affect the cipher. And so my question or a suggestion would be that we validate the actual value of the cipher when the component loads on init, and then error out if it's an invalid value. What do you think?
Yeah,
Yep.
no, that makes sense. That we should definitely do that. Go ahead, Deepanshu.
No. I was also saying the same thing. It makes sense that if we do it on the component level, then validating it makes sense.
Okay, cool.
I think okay, Tiago, I think is pointing out the difference between a generic cryptography library and a secrets encryption solution. Yes, that is true. I think Dapr is adding an abstraction on top of cryptography library. When we're not replacing cryptography library, we're actually giving a solution for encrypt and decrypt.
Correct, and this could be really paired nicely with the state encryption capabilities that we have today.
That is true. That is true. We could change the state store encryption to point to a crypto component.
Correct. Yeah.
And then use that instead of using the key like we're doing today and define.
Exactly.
Yeah.
Exactly. Yeah. Awesome.
Great. I'm not seeing any other questions. So if there aren't any, then I think that concludes today's call. I want to thank all the presenters and everyone for joining. And we'll get this uploaded to YouTube shortly. Thank you, everyone. Enjoy the rest of your day, morning, and evening.
Thanks, Nick.
Okay.
Bye, everyone.
Bye,
Thank you.
everyone. Thanks, Nick.
You.